Okay, so this is going to be sort of a review of a very big class I did, a very big lecture I did on graphing quadratics. The beauty is a lot of you guys now semi-remember it, right? And with the homework last night, at least with my group, you at least remember what happens when you don't have a b, right? And so forth. So first of all, let's just talk about a quadratic formula. Let's just remember what we learned about it. Y is equal to ax squared plus bx plus c. And please take notes. Even though we did this before, I'd like you to take notes. I think sometimes it sort of sinks into your brain when you write it down. It's like it's one more way in which we learn. Y is equal to ax squared plus bx plus c. So what does the a do? The a is a number, the b is a number, and the c is the number. And so when you actually see a quadratic equation, you will see a number there, and a number there, and a number there. And you'll have the y and the x squared, and the x there, right? And are they numbers? Yes, they will also stand for numbers, but they change. Y changes depending on what x is, okay? Have you guys learned about independent and dependent variables? I think maybe we talked about that last year, or maybe Nate talked about it in science. But you know how when you do a t-chart, you always put your x first? Remember that? Right? You always choose your x's. Y is dependent on what you choose for x. So y is your dependent variable. Y is dependent on what x is, right? X is not dependent on what y is. You never choose your y's first. You always choose your x's first. So I don't even know why I'm getting into this. But anyways, but the a, b, and the c are actual numbers. So what does the a tell us? All right, the a tells us how skinny or how fat, right? The parabola is. It's how skinny or how fat. Now, does anybody know what a would be to what would a have to be in order for it to be really, really skinny? I mean, give me an example. One would be just a regular standard parabola guy, right? Who's saying this? Who's talking? Okay. So like a 4 and higher would get its as the number gets bigger, the graph gets skinnier. All right? So if you had y equals 10x squared, it would be one really skinny parabola. Y equals 100x squared, it would be like unbelievably skinny, right? What would be an example of a fat A? One would be sort of normal, right? Well, can you have a 0? I mean, what would happen if you had a 0? If you had 0 for an A, you would no longer have a quadratic formula, right? You wouldn't have y equals x squared something, because the x squared times 0 is just nothing, so it would end up being a straight line, right? So it would have to be yes. So if one is sort of a normal parabola, and 0 is no parabola, it's got to be somewhere between the two, right? So it's got to be a fraction, basically, between 0 and 1, or between 0 and negative 1, right? You can have a very, very wide fat thing going downward, right? Or you can have a very wide fat thing going upward. But a fraction, basically, if that were a fraction, that would be fat. So this would be like, fat would be like fraction, right? And skinny would be like big number, right? All right, so that's one thing that A tells us. A also can be positive or negative, right? It also can be positive or negative. If it's positive, it's happy, and it's smiling, right? Oh yeah, okay. And if it's negative, negative thoughts make very frowny faces, right? So it's going to be a downward parabola. Pretty obvious, right? So that's what A tells us. All right. What does B tell us?
Like where it is? Like where it is.
What does it do? It moves what?
It moves it off the line.
It moves what off the line?
Left and right. It moves
The thing. Yes. What's that
Center
thing? The center of the universe. What is that called?
Well, it moves the vertex.
Vertex. Who said vertex? Yes, vertex. It moves the vertex, right? It's where the vertex is that final point where it curves and comes back up again. It changes direction, right? So it moves the vertex left or right, right? So it moves vertex left or right. If B is 0, where is the axis of symmetry? Remember the axis of symmetry? Remember like a parabola. If you have an axis of symmetry, if you have a parabola, boom, it's going to be, oops, sorry, I'm not very good at this. It's going to be, still doesn't look right. All right, you know what? We're going to move the axis of symmetry. Now it looks right. All right, so that's my vertex, right? I know that the distance from here to here is exactly the same as the distance from here to here. These are symmetrical, right? Completely symmetrical, each half of the thing. Because they're symmetrical to the axis of symmetry. That's what this is. The axis of symmetry, right? If B is 0. In other words, if there is no B, right? Would you agree with me? Y is equal to ax squared plus c. No B. B is 0. Where is the axis of symmetry?
And the y-axis.
The y-axis, exactly. Does that make sense? There's no B, so it moves there's nothing to move it, the axis of symmetry or the vertex off of the y-axis. So it's on the y-axis. If B is 0, y-axis equals axis of symmetry. Right? Vertex is on y-axis. Okay? All right, what does C do? It moves it up or down, right? Moves vertex up or down. All right, what else does the C tell you? What? Well, it doesn't technically, if there's a B, the C doesn't tell you where the vertex is. Because the B is moving it away, right? So I mean, if B was 0, then yes, it would tell you where the vertex is. Because wherever it is, it would be where it would cross the y-axis. Notice this is in the form of y equals. What other equations do you know that are in the form of y equals? That are for straight lines. What are those called? Slope intercept, right? So Violet, if you had slope intercept, what's that formula? Y equals straight line. Y equals mx plus b, right? Y equals mx plus b, mx plus b. Now that's a straight line. Why would I be talking about this? Because look, the last number does not have a variable attached to it. It's a constant. And what is that? It is your y-intercept, right? The same thing is true. This is in y equals form as well. But it's a parabola. But the last number has no variable, right, attached to it. It's a constant. That is also your y-intercept. So C is also your y-intercept. It's where your parabola crosses the y-axis. Your y-intercept, right? Make sense? This is the tiniest eraser I've ever seen. Okay. So. Oops, I'll turn it. All right. Can I erase some of this? All right. Can I really erase all of this? You guys got this? No? Not yet? Sorry. It's your y-intercept. So if you know this, It will help you immensely. I mean, it will take all the guesswork out of it. You immediately know, oh, well, if I have y equals x squared minus 7, I immediately know what's the b. There's no b. B is 0, right? That means where is the vertex? It's on the y-axis. I immediately know that. So I just go down 2, 3, 4, 5, 6, 7, and I put a dot. Why would I put a dot there? Because that's my y-intercept. It's also my vertex because there's no b, right? But it is my y-intercept for sure. And then, now that I have moved my vertex, I have this lovely thing called y equals x squared, which is, the way I teach it, is called, you guys rock, okay? Am I even on this thing anymore? Hang on. Can't really see that thing very well. Can I erase this now? Yes? Okay. Now, I'm going to first show you briefly how you first learn to graph these things. And then I'm going to show you my way. And you probably, some of you already know it, but that's okay. So if I were going to graph this, the normal way, the way you first learn it, is you'd use a t-chart. So I've got y equals x squared minus 7. And I would use a t-chart, x and y. And again, my x is my independent variable. I get to choose whatever I want for the x. It's completely independent of anything except in my brain, whatever my brain wants to do. But my brain wants to do things simply, so I'm not going to do hard ones, right? I'm going to choose easy ones. And y is dependent on what I choose for x, right? So I'm going to say for this, well, actually, I'm going to do it the way I was taught, which was horrible, absolutely horrible. Okay, so what would I do? I would say, okay, I would say -2, -1, 0, 1, and 2. Okay? Now I'm going to see what I get when I do this. All right, if x is -2, -2 squared is positive 4. -2 times -2 is 4, right? -1, oh wait, excuse me, sorry. So it's 4 minus 7, which is -3. All right, -1. Y is equal to -1 times -1, which is positive 1, minus 7, minus 6, right? All right, 0. Y is equal to 0 minus 7, so minus 7. All right, 1. This is going to be the same as this, right? 1 squared is 1, minus 7 is minus 6. And this is working fine. All right, of course it's working fine. Never mind. Okay, 2, 4 minus 7 is minus 3, of course. Okay, so here I have created a bunch of coordinates, right? These are actually coordinates, like -2, comma, -3. Now, do I write them all out like that? No, this is the same thing. So I'm just going to graph them. So I go -2, and then -3. 1, 2, 3, boom, put a dot. And I have -1, -6, 4, 5, 6, put a dot. And then I have 0, -7, dot. And then 1, -6, put a dot. And then 2, -3, put a dot. And then there's my my parabola, right? And this is not a V. Is that clear? It's not a straight. They're not straight lines. They are curved, right? Very different. Parabola is not a V. But so that's how I would do it. It took a little time. It wasn't too hard. I used this T-chart, and I got all my points. Now, the way I suggest you do it is, if you remember that little map of what I just explained, what all these things represent, then all you have to do is realize this is y equals something x squared. You know, if it's y equals x squared, like it would be standard parabola guy, and I do that after I figure out where. The B moves the vertex left or right. The C moves it up or down. Once I find that place, I pretend that place, that vertex, is like my origin. And I go over 1, up 1, over 2, up 4, right? So this is my standard parabola guy. Let's just identify what standard parabola guy is. Y is equal to x squared. If I did a t-chart of this, I would say 0. I'm gonna only do half of it. I'm not gonna do the negative side. You know what I mean? Since I know it's symmetrical. If x is 0, y is 0. If x is 1, y is 1, and f is 2, y is 4. 2 squared is 4. Right? So this is the part I memorize. And I memorize it like this. Over 1, over 1, up 1, up 1, over 2, up 4. Okay? That you have to know in your brain all the time. If you know that, it's the easiest. You'll be able to graph quadratic equations 10 times faster than all your compatriots in high school. Promise you. Promise you. Very few people will learn this method. I don't know why, but very few will. They will learn a very long, drawn-out, exhausting way, and you will whip it off, and they'll say, "Wait, how'd you do that?" Right? And you will be the pro. Okay. So look, this is standard parabola guy -7. So I go down to -7, and I just do it's standard parabola guy at -7. Over 1, up 1. Over 2, up 4. Over 1, up 1. Over 2, up 4. Or I can just do one side, and I could say, well, this is 2 away from the axis of symmetry, so I go 2 this way. This is 1 away, I go 1 this way, right? But so it's really quite simple. Now, okay, so everybody should know this for now. This should have been pretty, pretty much a review, and you've got it, right? Just to 5. I just want to be sure. It's okay if it's review, because, Adam, where are you, buddy? There you are. Okay. So, all right, where are you? Does it make sense a little bit? Is it making a little bit sense? Okay, awesome. All right, so now, what am I going to do? Oh, yeah. Okay, so I'm going to leave that because that is our most important piece of information. Okay, so what if A does not equal 1? Right now, standard parabola guy requires A, the number in front of the x squared, to be 1. That's standard parabola guy. Standard parabola guy, right? Standard parabola guy. Okay? A is equal to 1. That's interesting. So let's try an A does not equal 1. A equals something else. Let's try this. Y is equal to 2x squared, I don't know, -2. Okay? So let's draw our graph. What do we know? Does it have a B? What's B?
0.
B is 0. Oh my God, what does that tell us? What? Yeah, the y-axis is where the vertex is, right? The y-axis is the axis of symmetry. Okay, so that's awesome. So that means this is my y-intercept and my vertex. So I just go down 1, I go down 2, and I put a dot. That's my vertex. Right?
And then you do doubling out, right? So
Yes,
you go over
exactly. Exactly. So let me just draw these lines and these lines so I have them. Okay, so all I'm going to do is this is not standard parabola guy. This is standard parabola guy times 2. So I do this. I go over 1, up 1 times 2. Does that make sense? Or I could do it this way. I could say over 1, up 1 twice. So I could do this. I could say from this dot, I can go over 1, up 1, and then up 1 more time, twice. Put a dot, right? Over 2, 1, 2, up 4 times 2, which is 8, or 4 twice. 1, 2, 3, 4, 1, 2, 3, 4, put a dot. All right? Now, I could do the same thing on the left side now. Over 1, up 1 twice. Over 2, up 4 twice, right? Or I could use my axis of symmetry. I know that this is 2 away from my axis of symmetry, so I'll go 2 away from my axis of symmetry there. I know this is 1 away, so I'll go 1 away. And now I just draw my beautiful, beautiful vertex. Parabola, right? It's pretty easy, really. If you know this, if you use this, and you have to realize that always starts at the vertex, okay? All right, let's try another one. Let's try y equals 3x squared minus 10. All right, so we'll just do it here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Am I in your way for people to see on my left? Okay, so would you agree with me? That's right. B is 0. There's no B, right? So it's going to, my y-intercept is -10. I put a dot at -10. That is also my vertex, right? And so I'm now going to just use standard parabola guy times what?
3.
Times 3. So I'm going to go over 1. I don't go over 1 over 1 over 1 times 3, right? The only thing that gets multiplied times 3 is the up one. So I go over 1, then I go up 3, over 1, up 1, up 1, up 1, 3, right? 1 times 3 is 3. Over 2, 1, 2, up 4 times 3, which is 12. So 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my dot. And then I know that this is over here, and I know this is over here, and now I just draw my graph, my parabola. Very, very quick, very, very easy, right? So now, let's look at the B. The B is not, it adds a level of complexity, but it's not a huge amount of complexity, right? But the B merely is going to move the vertex left or right, right? And once we figure that out, where the vertex is, if the vertex were over here, right there, then I would say, say that vertex, say there was a B in this, and that was the vertex, I would go over 1, up 1, up 1, up 1. Over 2, up 4, up 4, up 4, 3 times, right? No big deal. I just use that wherever that vertex is. So, would you agree with me that the most important part of graphing a quadratic equation is figuring out where the vertex is? Don't you think? Right? This part's a piece of cake, right? It's just you got to figure out where the vertex is. Then it's no big deal. Over 1, up 1. Over 2, up 4, right? So, okay. So, now, in order to find out how the B affects the vertex, you have to use a formula, and it's called the axis of symmetry formula. All right? And it's a very, very popular formula. Important formula. Not very popular. What am I saying? Yeah. You'll see it on YouTube everywhere. The kids are talking about it up and down. Okay. So if you had, let me just write the axis of symmetry. This formula starts with x equals. That's very important. Most people, when I ask students, what is the axis symmetry formula, they say it's negative b over 2a. No, it isn't. It's x equals negative b over 2a. That x is important. X is equal to negative b over 2a. That's a b, not a 6, right? Negative b over 2a. Very famous formula. Very famous formula. So let's try one. try one. Y is equal to x squared plus 6x, let me think about this for 1 second, 18, 9, plus 12. Okay? So let's use our formula. X equals, and I recommend you write the actual, well, here, we'll just do it right here. X is equal to negative b over 2a. I recommend that you write the formula each time because you get it, it drives it home into your brain. Equals, what would be on the top?
Negative 6.
Negative 6 over 2 times what? 2 times 1, which is 2. What does that equal? Negative 3, right? Okay, that says my axis of symmetry is x equals negative 3. So if I come over here and graph this, 1, 2, 3, this, sorry, I can't do that on the side. That is my axis of symmetry. Okay? That says x is equal to negative 3. X is always negative 3. Even up here, x is negative 3. Even down here, x is negative 3. It's going to be a vertical dashed line. Why did I draw that line? Why is it significant? What? The vertex is going to be there somewhere. That is going to be my vertex. It's going to be on that line, which means my vertex, remember a vertex is a point, right? It's going to be x comma y, right? I know now that my x is what? Negative 3. That is big. I don't know my y yet. I know my x, right? I know my x is negative 3. That's huge. I just need to figure out my y now to find my vertex. How do I find my y? Plug it back in. Right, exactly. So I'm going to plug it back in. I hope it's not way up there. What am I doing? Okay, so this is what I recommend. Don't do it in your head, Dave. Right? Right? I would suggest you go negative 3 in parentheses. The parentheses are really important, and you put squared. And then plus 6 times parenthesis negative 3 plus 12. This is where 90% of the mistakes are made. Because if there's a negative sign here, they somehow mess that up. I don't know quite how. But negative 3 times negative 3 is positive 9. 6 times negative 3 is minus 18. Plus 12. Now look at this. This is interesting. This number is twice this number. Look at that. You will find that is, I think, always the case. Or at least almost always. And so 9 minus 18 is negative 9. Negative 9 plus 12 is what? 3, right? So I know my y is equal to 3. Oh, wow. So there's my vertex. That's really cool. So all I have to do is go negative 3, up 3, negative 3, up 3, put a dot. That's my vertex. Now what do? I look at this. What is that? The standard parabola guy. Is it okay to use that from here? Yes. All this did was move my dot. It moved my vertex. But it's now just plain old standard parabola guy. Right? Make sense? You get it? So I've already found my vertex. And I just go over 1, up 1, put a dot. Over 2, up 4, put a dot. Over 1, up 1, put a dot. Over 2, up 4, put a dot. And draw my parabola. Okay? So that is the end of the lecture, obviously, because it's the end of the class.